Okay, this worksheet here has some challenges on it. Working with the cylinders, you were given just a very small amount of information in the textbook about cylinders and what they look like when they are cut at different depths. And then they give you this problem here that is a pretty good challenge, besides not seeing all the detail, not knowing really what in the world is going on completely with this slot. So I'm going to zoom up a little bit, and I have tried to sketch in some of the solution, at least isometrically. So sketching down to where the ellipse would intersect a line on each side, and then sketching in what I believe is the same, since it's a pipe, it's going to be symmetrical, and so you have this flat surface that's cut out with a notch, so you'll have a flat surface down here as well. So there is like a tiny piece missing here that they failed to include in the sketch problem to work with. Remember, you don't have to create the isometric, no pictorial required. You're sketching just the front, top, and right side. Then on the other cylindrical problems, I want to show you some examples of what happens when you slice a cylinder with or intersect a cylinder with a prism. So this is one example, or three examples, of some multi-view drawings that are similar. So here, this one has just a step cut out of it, a little piece cut out of the side of the cylinder. So the edge is now in the front view a little further back on the circumference. So you find out where that edge is by using the miter line if you want, or by just simply measuring back the depth and drawing the depth in the top view, in this case, and a line all the way across, and where it strikes the circumference, that's where the line is. So essentially, that is what this one looks like in your front, top, and right side view. Okay, the next one shows multiple steps cut out of a cylinder piece. And this creates, when we cut a cylinder right at the midpoint, basically creates a horizontal line all the way across. This horizontal line, 15, 16, is actually this arc number 4 all the way around between 7 and 8. Then 21, 22 is actually arc 3 here. And 7, 8 stretches between 11 and 14. 9, 10 matches up with 5 and 6. And arc 1 between 5 and 6, this arc, is also on 9, 10 and is represented by 19 and 20 over here. So as you cut back into the cylinder, your edges of the cylinder and where that plane intersects the circumference makes the cylinder look narrower as it steps back into the object. So this shape here and here is what you have on problem 2. Here and here. This is just the same kind of look as what we have over here. Okay, keep that in mind. Now this one is not a pipe, it is 2 cylinders stacked on top of each other, concentric cylinders, solid. But when we cut across the whole path, the side of it, it creates these edges of intersection with the circumference. So 2,6 is actually here at 0.17, 8,14 is at 18, 9,15 is at 19 point, and 3,11 is at 0.20. Arc 22, the intersection of the 2 cylinders, turns into partially the hidden line between 8 and 9, and then the rest from the center up is solid from 10 to 9 here. So from 8 to 9 it's hidden, from 9 to 10 it's solid, 8 to 7 it's solid. You're looking down on top of it, it's the intersection of the small cylinder plane with the large cylinder plane. So construct all of these in the same way that we've been doing them. Find the back of a sheet that's open and remove it out of the textbook and block these out. They are 6 by 6 by 8, so they should lay out on the back of the sheet practically in the same manner as the other. You'll have to do some analysis and figure that out.